Okay, page 3 of integration. This is kind of an interesting page because the first half of it is for core, so that means everybody should do the first half of this. When we get to the second half of it, I encourage you to go ahead and watch the video for the last couple problems because you can see what the difficulty level is for the harder problems. But you're not responsible for it unless you're going for like a 6 or a 7 on the exam, maybe a 5. Then if you are, then I would go ahead and study this part also, and we're going to do the rest of the pages later, but for now we're going to focus on the core. Okay, so let's see. For the first one, it gives us a curve y equals negative x squared plus 4, and it asks us to find the zeros of this curve. So let's go ahead and do that. It gives us a function, so the first thing we're always going to do when we're given a function is we're going to put it into y equals negative x squared plus 4, and we graph it, and then it says to find the zeros of this curve, and like, let me put it in zoom standard so that it's exactly how it's going to appear on your calculator when your calculator's just been reset. I was doing some other stuff on the calculator. That zoom standard is option 6, and we're going to find the zeros of the curve, which means we're going to find the x-intercepts. We're going to do second calc second calc 0, which is option 2. And the first thing you're going to do is we're going to find this left x-intercept. So we're going to move the cursor to the left of that x-intercept. And maybe the easiest thing to do is type in a number like negative 3, and it'll move it there. And then we're going to move it to the right of the x-intercept. So maybe it would just be easier if we just typed 1. And then it marks from the left side and the right side of the x-intercept, and then it asks for a guess. The guess doesn't matter, we just hit enter, and then it gives us that the left x-intercept is negative 2, which you might have been able to see just from looking at the grid since it happens to go through a whole number, but it's not always going to go through a whole number. So one of the zeros is at x equals negative 2. And the other 0 appears to be at x equals 2, but let's make sure. We're going to do second calc 0, and the left bound we're going to put like 0, and the right bound we'll put like 4, and then we'll hit enter for the guess, and it says that the second intersection with the x-axis is 2. So we found both of the zeros. Find the point where this curve cuts the y-axis. So that would be the y-intercept, which we can easily find by doing trace 0. And the y-intercept is 4. Okay. Below is shown the graph of a piecewise function f. Do you remember piecewise function? It's a function made up of multiple functions, made up by a horizontal line segment and part of the parabola negative x squared plus 4. So you can see that this part of it, doesn't it look like what's on the calculator, but the left side is not? So the left side is a horizontal line, like they said, and the right side is a piece of the calculator function. The area under the graph of f above the x-axis has been shaded. So let's see what they want us to do. Probably they want us to find the shaded area. Find the area under the curve of f in the interval negative 5, 0. So basically what they're saying is, first, find the area over here between negative 5 and 0. Negative 5 and 0. So it's just a big rectangle. So there's a couple ways you could do this. One of the ways you could do this is you could just look at the rectangle and you could say, well, the height of the rectangle appears to be, let's see, it appears to be 4 because we know the y-intercept of the parabola is 4, so we know that the height of this is 4. And we know that the width appears to go from negative 5 to 0, so it would be 5. So the area of this rectangle appears to be 20. So you could just do it using length times width. If you would like to, you could do the integral from negative 5 to 0 because those are the left and right edges of the rectangle, and then the height of the rectangle is 4, or the function of the rectangle is 4. And you could just do this integral, and then you could also find that the answer is 20. What about D1? Write down an expression for the area under the graph of f and above the x-axis for x is greater than 0. So in this particular case, what they want is they want this area here that is underneath the parabola, and they only want the positive side. So for this, let's use the calculator second calc integrate function. We already have the parabola in there. So we do option 7, which is the integral, and then we say the lower limit is 0 and the upper limit is this intersection point, which we know is 2. So we're just going to put upper limit 2. And then it's going to color in exactly the part that we want. How nice. And it's going to be 5.33 is the answer. And then it says, oh, and then we found the area, right? Oh, we didn't write down the expression. So write down an expression for the area under the graph. So it would be integral of, from 0 to 2 of negative x squared plus 4, which is this function here, right? Dx. So that would be the answer for part 1, and part 2 would be 5.33. Find the area of the whole shaded region. Okay, so that's easy. It's just basically we need to add the rectangle part to the parabola part. So it would be 20 plus 5.33 equals 25.33. Okay, and so now we're done with all the core problems for integration. And now we can just take a quick look at some of the advanced problem types if you would like to. Otherwise, you can stop viewing, but if you're going for a 5, 6, or 7, please continue on. The area of the region bounded by the graph, f of x equals negative x plus 1 quantity times x minus 5 quantity. The x-axis, the y-axis, the vertical line x equals a, where blah, 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 blah. Okay. This it might be a little bit confusing, so I'm going to draw you a little picture, okay? Remember that whenever they give you a curve, basically the curve is like defining the top edge of the function. And then you look, and then the bottom edge is always going to be the x-axis, so there's the bottom edge. And the rest of it's defining like the left and the right edge. And so the y-axis is actually the left edge, right? And then it says the vertical line x equals a, where a is greater than 0, is equal to, a is greater than 0 is equal to, okay, oh, wait a sec. What is equal to 24? The area of the region bounded by top edge, left edge, bottom edge, and right edge is equal to 24. So the area is 24. And the right edge is this line here. I'm going to draw a different color, not red. So this line here, which is x equals a, is the right edge, okay? And they don't tell you where the right edge is. And they want you to find the right edge so that this area here, defined by these edges, is exactly 24, okay? And there's a lot of ways to do this, but I'm going to introduce the easiest way to do it, I think. And then later we're going to do problems where maybe you're going to see the more mathematically rigorous way to do it, but it would require a lot more math knowledge and proper execution of algebra, etc. So we're going to do it the easy way first, okay? So what I'm going to do is I'm going to write this out as a integral. So the integral is going to go from 0 to a, and a is a unknown number. And then in the middle, I'm going to have the function. And then it's going to end with dx, okay? And so for this one here, I'm just going to go ahead and you can do this with the graphing function and the option second calc integrate, but I'm going to do it with option 9 to show you how to do it with this, okay? So I'm going to put 0 here for the bottom limit, and for the top limit I'm not going to put anything for now. And then I'm going to put negative x plus 1 x minus 5, okay? And then for the variable I'm going to put x. It's always going to be x for us. And then what am I going to put for a? Well, I don't know. But this is one of those times where it's like I'm pretty sure that the answer is going to be a whole number. So it makes guessing a valid option. So I'm going to just put like a number that I think may be right. So I'm just going to randomly guess 5 because that sounds like a good answer. And I get the answer 33.3. But I want it to be 24. So it looks like I made the area a little bit too big. So what if I just change 5 to a smaller number, like 4? So now I'm going to go back and I'm going to change, oops. Can I go back here? Yeah, I can. So I'm going to go back and change the top limit to 4. Okay, 4. See, 4 is correct. And 4 is indeed slightly smaller, but it's still not 24. So let's try 3. We could start the other way. We could put in 1 first and then put in 2, right? So I'll put 3. Oh, there it is. On the third try, I guessed it. So, see, it's not that hard to find these answers just by guessing, because most of the time in math applications, the answer is going to be a whole number. So, A is equal to A is equal to 3. Okay? All right. Number 3. The area of the region bounded by the graph f of x blah, 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 and the x-axis between A and 3, where A is between 0 and 3, is equal to 6. So basically for this one, again, they have defined a top edge with this function. I'm just drawing a random curve because I don't know what it looks like. And then they got x equals a, which is the left edge. And then they have x equals 3, which is the right edge. They know that that value is 3, though. And they say that the area of this inside is 6. Okay, but we know that we don't know the a value. We just know it's between 0 and 3. Well, doesn't that make guessing very easy? Okay, so we're gonna first draw a partially shaded diagram, and to do that, I guess we do need to graph this to get like a nice picture of what x plus 1 over x looks like. We didn't even do that for number 1 because it didn't ask us for a graph or anything. We could just kind of imagine what it looked like. But, you know, always a good idea if you have the time to graph what you're looking at here. So this is the function. And what we're looking for is an interval from something to 3 under this graph where it's equal to 6. Okay? So I'm gonna draw this again. And so instead of looking like I just drew it, it's going to look more like this, right? I'm copying from the sketch there, from the calculator. Okay, so there's my partially shaded, the shaded part is going to be here. So, and then this is going to be 0, right? Because we know that a is between 0 and 3, okay, but we don't know exactly what a is. So actually it could be just 1 or 2. There's only 2 possible numbers, assuming that the answer is a whole number. Okay, and now we're going to find the value of a. And it says give your answer correct to 4 significant figures. Whoa, maybe this is not going to be a whole number answer. Okay, so let's try it. This time, instead of using the math function, we've already graphed it, so why don't we use second calc integrate. So we'll do second calc, and then we'll do integrate, which is 7. And we're going to put, we'll put 1 for the lower limit, and then we'll put 3 for the upper limit. And the answer is 5.09. So I tried 1, a equals 1, and that gave me 5.09 area. I would like it to be an area of 6, so I need to make it a little bit bigger. That means I need to move my a slightly to the left. So now I'm going to do second calc, intersect, and I'm going to put, oops, not intersect, second calc, and integrate, and now I'm going to put 0.5 to 3. 0.5, enter, 3, enter. And now my answer is 6.16. So I put in 0.5, and now it gives me 6.16. So now I'm going to try, I need to make it slightly smaller so that it's 6. So now I'll try like between 0.5 and 1, closer to 0.5, I'm going to try 0.6. Okay, so second calc, integrate, 0.6 and 3. Oops, something didn't go right. Graph, second calc, did I say integrate again? I keep getting mixed up. They both start with I. Okay, 0.6 and 3. Okay, so I tried 0.6 and it gave me 5.929. So this is, it's somewhere between 0.5 and 0.6, right? So you can see that I could eventually get there with this method, but since this one is not a whole number, let me show you another way to do this, okay? So we're going to go to math, and I'm going to go down to the function solver or equation solver or the solver, which is the bottom. There it is, solver. It's the bottom one. And with the solver, what you do is, on the left side you put your integral expression, and the right side you put 6, and then it tells you what value is going to give you exactly the area of 6, okay? So I'm going to write out the expressions I'm going to put here. So the left side is going to be the integral from a to 3 of x plus 1 over x dx. And then the right side is going to be 6, right? Because the area we want is 6. The expression for the area is this integral, okay? And the thing that we don't know is a. So what we're going to type into the calculator is, we're going to type in exactly this for E1, except for a, we're going to substitute x. And then for the right side, we're just going to, for the E2, we're just going to type in 6. Okay, so let's do that. We're going to do math. And then we're going to do integral, which is 9. And then we're going to put x. And then for the top, we're going to put 3. And then in the inside, we're going to put x plus 1 divided by x. And then this variable is x. And then for E2, we're just going to put 6. And then we say, okay. And then what we're going to do is, on top of this value here, we're just going to type alpha solve. I think it's thinking. And there's the answer, 0.569. 0.569. So, we need 4 significant figures. So actually, we knew that the answer was between 0.5 and 0.6, but the precise answer, according to the calculator, is 0.56926, which is rounded to 4 significant figures, would be 5693. Okay, so that's how you can use the calculator to solve this integral with an open unknown value there, without doing any integration, without doing any algebra.